This is a lesson for Chapter 5, Section 5, titled Standard Form, Day 1. So let's take a look at the first type of problem. We'll see it asks us to find the x and y intercepts of the graph of each equation. So let's talk real quick about what those represent. If I looked at a coordinate plane, and I've got the x-axis and the y-axis, the x-intercept is going to be where it crosses the x-axis. So notice this point is going to have a y value of 0. So it's going to be some x value, comma 0. And then we're going to end up with a y-intercept. And that y-intercept is going to end up having no x value, or 0 is the x value. And then it's going to have some sort of y value. And so the reason why it's nice is that it's quick to come up with the two intercepts, and we'll see why that's the case in just a moment. And from there we can draw the line between those points and have a line. So moving on to our first problem, it gives us this equation, and it's really only a great method for finding x and y intercepts when we have it in a form that makes sense to us, to make the finding the intercepts quick, and that's what the standard form is for. So standard form is typically when you have the x value, then your y value, then you're equaling your constant. So that's what standard form looks like. So it's ax plus by equals c, where a is some sort of constant of x, b is a constant of y, and c is just what these two values equal. And so that's what we have here. And so what we're going to do is we're going to set y equal to 0 to find that x-intercept. So let me actually write that part down. So we're going to find the x-intercept we'll start with. And when we do that, we're going to set y equal to 0. So when I do that, I've got this, 2x equals negative 6, because the y term cancels out when I set it equal to 0. So you can see the quick division problem there, and you get x equals negative 3. So that's the x-intercept. So it's negative 3 comma 0. That's the point where the where the graph crosses the x-axis. For the y-intercept, we're going to set x equal to 0. Because again, notice how the y-intercept is on the y-axis. You don't go left or right. So when you do that, the x term cancels out, and we're just left with 3y equals negative 6. So then we have y equals negative 2. And so that would be our point, 0 comma negative 2. So you can see how quick it can be to find 2 points for the line when the equation is in this form. To put it in slope-intercept form, we'd have to do a little work. We'd have to subtract the 2x, then divide by 3. And here, this might be just as quick or even quicker. Sometimes I just say cover up the x term and solve for y. Cover up the y term, solve for x, and you get your 2 points pretty quick, and then you can graph them. For this one, again, the x-intercept, you're going to set y equal to 0. So when you do that, the 4y cancels out, and we're just left with 5x equals negative 12. Divide by 5, and you've got yourself your x-intercept. So negative 12 fifths. If you want to change it to a number that's easier to understand, it would be negative 2 2/5. And that would be the x value, and so y value was 0. That's the ordered pair to represent the x-intercept. The y-intercept, all you're doing is you're setting x equal to 0. And when you do that, you cover up the x term, and all I've got left is a negative 4y equals negative 12. So it's just a one-step equation. You divide by negative 4, and you end up with y equals 3. So it's just another way to graph a line, and it's quick as long as the equation is in a form where x and y are on one side, the constants on the other. If you had to put it in the standard form, then it takes a little bit longer to deal with. So here we've got the x-intercept. We're going to set y equal to 0, so the y term cancels. We're left with negative 4x equals negative 8. So right away I see x equals 2. So again, the x-intercept is 2 comma 0. The y-intercept is when I set x equal to 0. So setting x equal to 0 cancels out the x term, leaving me with negative 2y equals negative 8. So I divide by negative 2, y is 4. So 0 comma 4 is that point. So that's finding x and y intercepts. And the next set of problems is going to ask us to do the same thing, but graph. So I'm going to find the x and y intercepts to start with. So for the first equation, I cover up the x term, and I'm left with y equals negative 10. So I can't fit negative 10 here, so I'm going to have to go by 2. So I'm going to tell the reader that this is 2, 4, 6, 8, 10. And I'll start down here at negative 10. And I'll go by 2's here as well. So this is 2, 4, 6, 8, and so on. And so from there, I'll find the x-intercept. Now the x-intercept has a little bit more work. Negative 5x equals negative 10. And then I just divide by negative 5, so x is 2. So positive 2 would be right there, and then you can draw the line between those points. So looking at this next one, the x-intercept is going to be negative 3x equals 12 when I set y equal to 0. So I have to divide by negative 3, and when I do that, I'm left with x equals negative 4. So I go over 4 spaces to the left, put a dot, and I look at the y-intercept. I'm left with negative 6y equals 12 when I cancel out the x term, and so y equals negative 2 when I divide by the negative 6. So I go down 2 spaces, put a dot, and then draw the line between those points. So looking at the next one, again, I'm going to cover up the y term because I'm solving for x first in this case. 4x equals negative 24 when I cancel out the y term. Dividing by 4 gives me negative 6. So x equals negative 6. So I can't fit negative 6 on this. So I'm going to go by 2's again. I'm going to call this one 2. This is 4, 6, 8, and so on. So I'm going to put negative 6 right there. I'll go by 2's in this direction as well. So I'll call this 4, 6, 8 right here. And so my y-intercept, I cover up the x term. And so I'm left with negative 12y equals negative 24. So I divide by negative 12, y is 2. So I'm just going up 2 spaces and then drawing the line between those points. So let's move on to the last type of problem we'll see, and these deal with graphing horizontal and vertical lines. So whenever we have just y equals 6, there's no x value in the problem. What this means is that the x component had a coefficient of 0. This is the same equation if this is a 6 here. And what we end up knowing is that since we have a y value or an x coefficient of x is 0, that means the slope is 0. So this is actually in slope-intercept form here, and my y-intercept is 6. So I can't fit 6 on here, so I'm going to go by 2's again. So this is 2, this is 4, this is 6 right here, and so it's going to be this horizontal line that goes right through y at 6. So whenever the slope is 0, we've got ourselves a horizontal line. So the slope was 0, horizontal line. We've got, anytime you've got just y by itself, that's going to end up being a horizontal line. When x is by itself, it's a little different. What that means is it was a 0y plus x equals negative 2. So there's no y term here. And since that cancels out, no matter what the y value is, x is always going to be negative 2. So we go over to negative 2 on the y-axis, and this is going to end up being a vertical line. So whenever we've got just x, no y, so there's no y here, no y value. So when there's no y value, that means we end up with a vertical line. And a vertical line has no slope or undefined slope, because slope is a fraction, and what that means is since slope is the change of y over change of x, x is not changing, so that means it's a number over 0, and that's undefined. So whenever we have a just x by itself, that's a vertical line. Just y by itself is going to be a horizontal line. Those are the types you'll see on tonight's homework. Good luck.